Hi.
So we're on page 248, 5.1, understanding direct proportion. So direct proportion, when you boil it down to, really is really simple. It basically says, as one thing goes up, the other thing goes up as well. So let's say, for example, you would have a direct proportion. Not only does one thing go up, but it goes up at the same rate. So let's say that you have a job, and they're telling you, hey, you're going to make $20,000 for your first year, but for the whole rest of the year, we're going to give you a 5% raise every single year. 5% raise every single year is more than what you can usually expect. So it's a pretty good raise. But that would be a direct proportion, because as one goes up, the other one goes up at the exact same pace. So if we look on page 248, they're talking about weight of strawberries and cost of dollars. So weight, and I'm just going to put straw on there for strawberries, and then cost. So for those, they talk about the weight of strawberries. It costs 1 pound, 2 pounds, 3 pounds, and the price is $2 a pound. So $2, $4, $6. So these are going to be direct proportions, because as one goes up, the other one goes up. But more importantly, you should always be able to say, so you might remember that, like, on the bottom one is usually Y, the top one is usually X. Nonverbals, yes, you guys remember on there, hey, I need you to get out of the way so they can both see the board. Yes, thank you. Nonverbals, this is usually Y, this is usually X. So you always want to go back to Y over X, and that is your unit rate. That should look familiar to you. Y over X is the unit rate. So you always want to take that top one over the bottom one, and you should always get the same number. So here I'm going to do Y over X, 2 over 1, 2, 4 over 2, simplifies to 2, 6 over 3, simplifies to 2. If at some point they're like, hey, you have 4 pounds, but now this is only going to cost $7, 7 over 4. That's when it stops being a unit rate. So in terms of at a grocery store, they might give you an extra deal, because they're like, hey, if you buy that 4th pound, we'll give it to you at a discounted rate. That works for them. But at that point, it fails to be a direct proportion at that point, because it's not going up at the exact same rate every single time. And again, that's why they call it a proportion, because the proportion and rates are pretty much the same thing. Or they're very similar, I should say. Alright, the other thing, so if I go, I'm going to do this in green actually. So Y over X is the unit rate. Specifically, you're going to want to write this down. This is probably the most important thing in this section. Y over X equals K. K is the name that we're going to give, and K is called the constant of proportionality. So you always want to remember what that is. I'm going to put that in yellow for you, star it, circle it, whatever it is. But Y over K, remember, Y is the bottom, K is usually the top one. Y over K, that's the constant of proportionality. That's what's always going to tell you, hey, is this rate going up at the same rate every single time, or is it not? So if we go to top page 251 here, it says a pet store. I'm going to write over here Y over X equals K, just so that I remember that for this one, because that's always what I want to go back to. A pet store owner uses a table to decide how many of a certain type of fish are put in the aquarium to tell whether the number of fish F is directly proportional to the volume of water G gallons. If so, given the constant of proportionality, tell what it represents. Excuse me. What it represents in this situation, then write a direct proportion equation. So they, in this case, they tell you, hey, we've got, this is G, this is F. So we already know that to find the constant of proportionality, we're gonna take what over what? F over G or G over F? To find the constant of proportionality, are we taking F over G or G over F? What? Nope, because remember, Y is always usually one on the bottom, X is usually one on the top. So you're doing F over G. So F over G equals K in this situation. That's why that's the only thing I wrote down to start with, because that's what I always want to remember coming back to. So it talks about, hey, you've got, that is gallons, and this is the number of fish. And then you say, yeah, this is volume of water, number of fish, but gallons and fish are really the biggest things I'm trying to remember. So it goes 4, 10, 20, 6, 15, 13, 13, 30. So if I'm always going back to, they said, tell whether a number of fish F is directly proportional to the gallons of water, then give the constant of proportionality, and then write a direct proportion equation. So we'll get to each of those one at a time. But the first thing, are they all directly proportional? To find out if they're all directly proportional, we need to do what? Divide what by what? Yeah, so do 6 over 4. 6 over 4, what's that when you simplify it? You can do it two ways. You can do it as a fraction or you can do it as a decimal. What? Not 2 over 3, because remember we're doing F over G. Yep. 3 over 2, do we want to do as a fraction or a decimal?
Fraction.
Okay. So 3 over 2, 15 over 10? What's it when you simplify it?
3 over 2.
Yep. What about 30 over 20? Is it a direct proportion? Yes, it is a direct proportion. I'm going to write that down first. The next thing, if so, give the constant proportionality and tell what it represents. So, give the constant proportionality is what? You guys figured it out 3 times in a row. What is it?
3 over 2.
Yeah, 3 over 2 is the constant of proportionality, and it represents that for every, think about it, 3 over 2, that means for every 1.5 fish, you have 1 gallon of water, because that basically means that at the end, this is like 1.5, 1.5 is a decimal, right? And this would be 1. So for every 1 gallon, you have 1.5 fish. For every 1 gallon, you have 1.5 fish. Or for every 1.5 fish, you have 1 gallon. So, for every 1.5 fish, 1 gallon. You guys would write it prettier. You would have more words on there, but just as, okay, well, she would write it prettier. You maybe not so much. But saying exactly what it means there. And then the last section, write a direct proportion equation. So, a direct proportion equation basically means, so you see on there, it's going to have whatever the bottom one is. So y equals kx. Start, circle it, that's what you're going to want to remember. This is a direct proportion equation. That's what they're looking for whenever they ask for a direct proportion equation. Y equals kx. Well, instead of y equals kx, here we have what? Something equals k what? Where do the f and g go? What?
F equals K times G.
Yep, f equals k times g. Now, is that that what your answer is then? No, it's not, because we have a k value. What is our k value?
3 over 2?
3 over 2g. And that would be your answer. Does it matter if you put 1.5 or 1 and 5/10 or 3 over 2? I don't care. It doesn't matter to me. Whatever way works for you, but you gotta remember, it does come back to y over x equals k and y equals kx. Guess what? These things are actually the same thing. Because if I have y over x equals k and y equals kx, if I multiply by x on both sides, this equals y equals kx. They're the same thing. But right here, this gives you a better idea because you want to have the idea. This, like, it is the same thing, but this gives you a little bit better, this gives you a little bit better idea of, hey, if I have, how do they actually relate to each other? Because if I have 1 gallon, then I can multiply it by 3 halves, and I'm gonna have, then I'm gonna get 3 halves of a fish, or 1 and a half fish. So it's just a different way of doing it, but this is what they want when it comes to the direct proportion equation. If we build on that one more time, another example, B, the table shows the distance traveled by a snail, d centimeters after t hours. And again, they show you this. So they're putting t hours, and d is, well, it's not, what's the distance in? I'm gonna put centimeters. So hours per centimeter for a snail. I know, it's probably what your idea of fun is, right? And then it goes 1 over 9, whoops, 218, and 3 over 21. So again, we're going to find that constant of proportionality, which is y equals kx, y over x equals k. That's the way we're remembering to do it. And when we do this, 9 over 1, we get 9. 18 over 2, we get 9. 21 over 3, we get 7. So what do we automatically know right away? It's what?
It's not.
It's not what? Think about even what the question was asking. It said, tell whether D is directly proportional to T. Is D directly proportional? Yeah, it's not directly proportional. So, no, it's not directly proportional. If so, give the constant of proportionality. We don't have to do that because the constant of proportionality are different. Then write a direct proportion equation. We don't even have to write a direct proportion equation. So paying attention to what we do on here, I mean, you're probably gonna write more than no. At least she's gonna write more than no because she's gonna do what she's supposed to. But you're probably gonna write no on this, and then basically you leave it at that, because if it's not directly proportional, you don't have anything else to worry about. So you guys can do page 252, guided practice 1 to 2, and then start on the assignment after that.
I want to